In this next section, 12.4, there are a couple of things that are introduced here. One is called apologize, I don't have a pen going on here. One is called the z-score. The z-score of a value. Okay, we'll start there. The z-score of a value is the number of standard deviations that value is from the mean. So they may tell you something like this. They may tell you that men's heights have a mean of 69.3 inches with a standard deviation of 2.8 inches. What is the z-score of a person? Let me not say of a person, of the height, right? A person would have this height, of the height 72 inches. So that could be a question that they ask. The way you find z-scores is very nice. You take your value that you care about, take away the mean, and divide by the standard deviation that they gave. So what do we care about? We care about 72. We're going to take away the mean that they gave us and divide by the 2.8. We're going to figure out how many 2.8s are in there. So 72 minus 69.3. You want to hit equals there. You don't have to write it down, but I will. 2.7 divided by 2.8, and we can realize that we have a 0.96 z-score. Usually z-scores, I put the 0 in there for emphasis, 0.96. I was going to say usually z-scores are rounded out to the hundredths, but that's its z-score. So that tells me that 72 inches is about one standard deviation above the mean. And so we can use that to compare some scores, but it is that nice, especially if they give you the mean and the standard deviation. They'll use it to compare two values. So there's a question that's going to be there a lot. Who did better? Student A got 8 on a quiz where the mean was equal to 6.3 and the standard deviation is equal to 2.3. Student B got 9 on a quiz where the mean was equal to 7.1 and the standard deviation was equal to 2.2. And so we want to know who did better. Well, the way to know who did better is to get the z-score of each. So let's get student A's z-score. Student A's z-score is going to be what they got on the exam minus the mean divided by the standard deviation. And then we'll compare that to student B's z-score. And they got a 9. That looks good. 7.1 was the mean and 2.2 was the standard deviation. Let's see. If we look at 8 minus 6.3, we get 1.7 divided by 2.3, and we get a z-score of 0.739 or 0.74. If we look at the 9 minus the 7.1, we get 1.9 divided by the 2.2, and we get a 0.86 z-score. So who did better? student B did better, not because they got 9 out of 10, but because they separated themselves by the mean from the mean by more than the other person. And so they'll take a look at some things and want to know, okay, who did better relatively? You're looking for the one with the higher z-score. Now, what I thought was interesting, and you'll watch me do this for a second. I'm going to go get some data that was in there. They were using this data, and I'll put that over here in a problem. So I grabbed this straight from the homework that's there. Sorry. Go in here and see if it will let me paste. It will. Okay, so let me put this down. So I can't see that very well. I don't think I can make that bigger, but it's because I cut and pasted out of there. So they're going to say something like this. Who had... apologize. Didn't realize I still had my highlighter on. They're going to say, who had better production? Country B or country D? They'll just pick two countries. And they'll pick either production, population, consumption. They use this a lot, this kind of graph. Now the numbers changed, but this is what we would have. And so we have this production that we're looking at. So we're totally focused on the production element right here. So let me erase that and just go through and highlight what we want. We want this production numbers. And we're not even looking at the other ones. Now here's the sad part. They didn't tell us the mean and the standard deviation, so we got to find them. And so I just wanted you to be aware of that. So to get the mean, we're going to take the 92.4 and add the 79.9 plus the 53.3 plus the 15.2 plus the 13.8 and divide by 5. So you're going to take the 92.4 plus the 79.9 plus the 53.3 plus the 15.2 plus the 13.8, and you're going to get an x equaling, or x bar, equaling 254.6 all divided by 5. And if I divide that by 5, I get 50.92. That's the mean. The standard deviation, unfortunately, we have to find as well. So now, if you remember how that worked, I got to take the 50.92 to get each one of the deviations, and then I need to square it. So, for sake of time, well, maybe I shouldn't do sake of time. Apologize. Let me come in here and not skip steps. So the deviations, I got to take the 92.4 and subtract away the 50.92 and get 41.48. Okay. And then I got to take the 79.9 and subtract away the 50.92 and get 28.88. And I got to do this all those times. 53.3 minus 50.92 is 2.38. 15.2 minus apologize, I was just thinking for a minute. 15.2 minus 50.92 is equal to negative 35.72, and 13.8 minus 50.92 is equal to negative 37.12. And the reason why I hesitated is I think this is all wasted effort. You can see, I mean, these countries unless I'm thinking about something wrong, you can already see which ones are going to have. I don't think it will allow me to redo that. So let me go in post and just paste this thing again and look at it unshaded. You can already see which one's better, because all we're going to do is find the average of these. Who separated themselves from average? Well, it's the same production level and things, so I'm not sure why they're giving us that. We can absolutely see which country is better. So see if you can answer those questions more directly, because obviously country B is better because country B had higher production than the average. But the average is coming from those numbers. It's the same groups that are there, so I'm not really sure why they're asking this style of question. Who did better? Absolutely country B did better as opposed to country D. So take a look at those. Let me know if there's questions. They could just ask for country C's z-score. That could be something that they do. Apologize. If they're not comparing but just asking for somebody's z-score, then you'll have to do this whole process. So let me finish it, because if the question is who did better, you can tell. But if they did something like, what is country B's z-score? Well, then you're stuck doing this. And what's this? You got to get your, let me move this down. See if it'll let me move it down. You got to get your deviations squared. And so you got to take this 41.48 and square it, and add to that the 28.88 squared, and add to that the 2.38 squared. So you could not write everything down. Add to that, I don't type it in as negative, 35.72 squared, and add to that 37.12 squared. And so the sum of those squares, I didn't write them down individually, but you're going to add them up as you remember, and the sum of those is 5214.122. And we're going to divide that by 4. So divide that by 4, and we get that number, and then we're going to take the square root of a big number and take the square root in the end, and we're going to get S is equal to 36.10. So the mean is 50.92. The standard deviation is 36.10. What's country B's z-score? Country B had a production of 79.9. We got to take away the mean, which was 50.92, and divide by the standard deviation, which is 36.10. So 79.9 minus 50.92 equals, divides by 36.10, and we get a z-score of 0.80. So it's not even a full standard deviation away, but still, it's above the average, which we already knew. So this is what you're going to do for part of the assignment. The other part is going to be calculating percentiles. Okay, and so as you calculate percentiles, you're going to have to work off of a list of data. So I'm going to come over here and grab a data set, and we're going to copy that. Ideally, the data sets they give you will be organized from low to high, and this one is as well. So in order to calculate a percentile, the percentiles that they're going to care about are usually standard ones like the 25th percentile, 75th percentile. So they're going to ask you to find something like P25, which is the 25th percentile. It's also known as quarter 1. Quarter 2 would be P50, and quarter 3 would be P75. And so we need to find these guys. So we've got to talk about what a percentile is. A percentile is the percentage of data that lies below a specified value. So if we want the 25th percentile, we need to find a number such that 25% of the data lies below it. Okay, so how do we do that? Well, we look at our big list of data. So in this, 1, 2, 3, 4, 5, 6, in this we have 40 pieces of data. So if we wanted to find, so I'm going to just note that we have 40 pieces of data. So if we want to find P25, step 1 is to take 25% of 40. Okay, you could do that on your calculator by using the percent button, or you could type in 0.25 times 40, and you're going to get the number 10 out. Now what 10 is, it's not our answer. 10's a location. So we need to go in here and identify the 10th value. 59 is that 10th value. Let's see if it will let me come in here. 59 is the 10th value. Now the problem with taking the 10th value is that it has 9 values below it. When it works out to be a nice number like 10, we're going to average the 10th and the 11th value. It's going to be right in the middle of those. So what's right in the middle between the 10th and the 11th value? Well, that is 59 is the 10th value, 60 is the 11th value, divided by 2, you're going to get a nice 59.5. If we were to find P50 or Q2, the second quartile, right, what changes? Well, now we don't want 25%, right? We want to find P50. So we need to take 50% of 40. And you know what 50% of 40 is, it's 20. So we're not going to take the 20th data value, 70. We're going to average the 20th data value with the 21st data value. So that's a 70, and you know what? The next one's a 70 divided by 2. Let's go in there and see that. So this right here that's underlined is the 20th data value, and this is the 21st data value. 70 plus 70 is going to be our guy, which happens sometimes. Divided by 2 is 70. P75 would be 75% of 40, which is going to be 30. And the 30th value is 78. The 39th value is 79. So we're going to take 78 plus 79 and divide by 2 to get 78.5. Those are how you're going to find the percentiles on there and use those percentiles in order to come up with other things like box plots that are there. Let's take a look at a box plot. When you have a box plot, and I have one drawn out here, and so what I'll do is, well, we can just look at it together right here. A box plot has several things in it. It has this line that goes through the middle. This beginning point is the low value of the data. I don't know why it's not letting me write up there. The low value of the data. This point right here represents the high value of the data. This first line is Q1 or P25. This second line is Q2 or P50. And this third line right here that creates the box is Q3 or P75. And so it shows you that a lot of the data, there's a big span of data that's in the middle here. So a bunch of the data is between, a quarter of the data is just between this value right here. Then you got this big widespread area for that last one that's there. So this is 25% of the data. 25% of the data lies here. Between Q2 though and P75, there's a huge separation that's happening there, and so you can learn a lot about the data by looking at the box plot. So they're going to have you investigate some box plots and draw them. So let me know if that becomes an issue, understanding those box plots. But they are just a labeling of Q1, Q2, and Q3. So that's what's in this section. Let's see if this video suffices, but if it doesn't, let me know and I can create other instructional videos. But please keep in mind there's instructional videos created in my math lab as well.